Recording in progress.
Okay, let's have a look at the method sample exam paper questions. So I will start to go through the exam 1 sample questions. The first question was to sketch a rectangular hyperbola. So basically you have this domain from -3 to -2 and -2 to infinity. Well, you should realize this is a vertical asymptote. That's why you have an open circle around this value. Okay, basically you need to label this one as x equals to -2. And also, we should recognize, yep, this is y equals to 1, a horizontal asymptote. Okay, next, I'm going to calculate this value. f -3 is 1 minus 1 plus 1 over -1, okay? Because when this is -3, this will be -1, okay? So basically this is 0. So exactly -3, 0. And the curve is going to approach to the left side of this asymptote. And then what I'm trying to do is f of 0. Calculate this value and you should get a 1 plus half, which is 3/2, 1.5. In the middle between these two marks. 0, 3/2, okay? So now if you substitute -1, the graph should go through 2, for example. So overall, your curve should look like this. Make sure your graph extends to both sides of the grid axis, okay? Sufficiently to the both sides. Okay, so I've labeled the asymptotes, the two axial intercepts, and the whole shape is there. And then find the value of x for which f of x is less than or equal to 2. So I actually need to make the reference to the graph. What that means is you sketch a horizontal line y equals to 2. Like that. Okay, basically, you just want to find the intersections between the horizontal line and the curve. Well, for this yellow part, it's actually intersecting all below y equals to 2. Okay? So this section is actually from -1 to infinity. And then don't forget, there is another side. Left side of this asymptote, this whole branch, sub-branch, is always below y equals to 2. So I will count -3 to -2, open bracket. Therefore, all values of x is going to be -3, -2, open bracket, union, square bracket, -1 to infinity, okay? 2 marks, I suppose. It's 1 mark for each part. Let's have a look at the second question relating to functions, graphs, domain, range. So firstly, you want to state the range of f. F is this quadratic function. Do a quick sketch. You should be able to see, okay, here we go. This is -9, this is -3, this is 3. So the lowest value is -9, and the highest value is positive infinity. So what I'm writing is range of f is -9 to infinity, open bracket. Now, notice this new notation, f of g, which is f g of x, okay? And this is the rule for the equation. So what I'm writing is root x bracket squared -9. Simplifying that, you should be able to get x -9, okay? And the domain of the composite function is going to be the domain of the inner function, which is domain f of g is domain of G, but it's not sufficient to write this line only. You need to specify what is domain G, okay? Domain G is 0 to infinity. So for composite function, domain of the whole thing is the domain of the inner function. Okay? Next, if I say h of x equals to x squared minus 9, I would like to have a maximal domain D such that G of h exists. So basically, you need your range of h being a subset to the domain of G, okay? Range of h is actually the y value or the expression x squared minus 9. It's a subset of domain G, which is 0 to infinity. So we can translate this mathematical sentence into an inequality. For example, you want every x squared minus 9 being greater than or equal to 0, okay? That means simply use the graph we sketched before. We'd like this function h of x to be greater than or equal to 0 for these two parts, at or above the x-axis. So your maximum domain will be negative infinity to negative 3, union 3 to positive infinity. Or if you wish, you could write it as all real numbers except for open bracket negative 3, 3 open bracket. Okay, this is another equivalent answer, but you need to make sure the close or open brackets are correct for the interval notation. All right, so that's question 2. Question 3, we want to find a general solution for 2 sine x equals to tangent x. Now, first of all, you need to translate the other side. Let's say sine x over cosine x, okay? Then you're not canceling the sine x term. Otherwise, you will lose a solution. So what I'm trying to do is I will rearrange first. Use your left-hand side to subtract your right-hand side, and it equals to 0. Then you take out a common factor, sine x, and you should get 2 minus 1 over cosine x equals to 0, which means the first possible solution using our factor law is sine x equals to 0. And then 1 over cosine equals to 2. That means cosine equals to half. So we recognize x0, x equals to 0, sine is 0. So you should have 0 plus or minus pi, plus or minus 2 pi, etc. Therefore, you should write x equals to k pi, and k is any positive integers. Then for the other case, cosine x equals to half, you should say x equals to pi over 3 as a basic solution, okay? Base angle. And don't forget, you could also have minus pi over 3 simply because of the symmetry of cosine ratio, okay? In the first quadrant and in the fourth quadrant. But remember, each time you rotate by x per 2 pi, it returns to the same position. That's why you need to add 2k pi to each base angle, okay? And don't forget, you should mention k is also an integer, all right? That's why the question is asking for the general solution. It has 3 parts, 1 part, 2 part, and 3 parts. And if you introduce the k or n, make sure you mention your categorization correctly. It's an integer, not all real numbers, okay? It's an integer multiple of 2 pi added to the base angle, okay? So that's question 3. Question 4, consider the simultaneous equations below where a and b are real constant. So now we want to find the values of a and b for which the simultaneous equations have no solutions. You know these two linear equations represent 2 straight lines. If they don't have any solutions in common, they will have no solutions, but they have to be parallel to each other, but are different constant, different, let's say y-intercepts, etc., okay, or constant terms. So what I'm trying to do is I will construct a ratio a plus 3 divided by 2 equals to 9 over a. So the ratio between x constant equals to the ratio between y constant. But then you want to make sure the third ratio is not equal to the first two ratios, okay? So I will say not equal to 3b over 5. Otherwise, if you make three of them equal to each other, then you will have two coincidental lines, okay? That's for infinitely many solutions. So let's have a look at the first equation. So I should have a times a plus 3 equals to 2 times 9, which is 18. Therefore, you should have a squared plus 3a minus 18 equals to 0. Now, you can say a plus 6, a minus 3, okay, equals to 0. So a equals to minus 6 or a equals to 3. For these two particular values of a, and they give the same gradient for the parallel lines. Then we have two cases. Case 1, if a equals to negative 6, then we have 9 over minus 6 equals to, actually not equal to 3b over 5. So minus 3 over 2 not equal to 3b over 5, okay? So minus, let's say, half not equal to b over 5. Therefore, your b value cannot equal to minus 5 over 2, which means this is the first set of values. When a equals to minus 6, your b value can be anything, real number, but not minus 5 over 2. Then the other case, case 2, if your a value is 3, then 9 over a not equal to 3b over 5. So 9 divided by 3 is 3. So 3b over 5 cannot equal to 3. Therefore, your b value cannot equal to 5. So when a equals to 3, your b value is any real number, but not 5, okay? Excluding 5. And that should be the answers to the question. These set and this set of values. So let's have a look at the next question. Okay. Now, we are talking about the ideas of average rate of change, average value, and the trapezium method. So what I'm looking at is a parabola. 2 minus x squared, okay? This is minus root 2, and this is root 2. The average rate of change, because we know this is an even function. From -1 to 1, I know the y values must equal to each other. Therefore, this is a horizontal line. So you can say the rate of change is 0, okay? But if you would like to calculate that, that's fine. You can say f of 1 subtract f of minus 1 divided by 1 minus minus 1. Notice this is 2, not 0, okay? You can divide by 0. And that will be 1 minus 1 divided by 2, which is 0, okay? So this is your answer. But for the average value, it's another story. So average value is the constant 1 minus 1. Integration from -1 to 1, 2 minus x squared dx, okay? So basically, this is half integration -1 to 1, 2 minus x squared dx. Now, you could say this is half times 2x, antiderivative of the integrand, minus 1/3 x cubed, minus 1 to 1. So, continue working on the right column. This will be half 2 minus 1/3. Subtracting half, minus 2, minus 1/3 times minus 1, okay? So half 5 over 3 minus half, let's say, minus 2 plus 1/3, okay? So basically, this is half times 5 over 3 minus half times minus 5 over 3. In fact, with these two minuses, you can get a plus. So the answer should be 5 over 3, okay? Adding up together. Okay, now we have 4 trapeziums of equal width used to approximate the area between the functions f and the x-axis from -1 to 1. The height of the left and right edges of each trapezium are the values of y equals to f of x as shown in the diagram. So we want to find the total area of the 4 trapeziums. So basically, you could do some simple calculations. This is minus half, this is half. But note a very important property here. Symmetrical, okay? So we could calculate the half of the total area, then double it up, okay? So let's say half of estimation, okay? You could say half times 1 minus 0 divided by 2 times the first y value and the last y value, namely 2 lots of f0, actually f of 0 plus 2 lots of the y value in the middle, 2 lots of f half plus f of 1, okay? So f of 0 is going to be 2. F of half, simply speaking, is 2 minus half squared, which is a quarter. So this will be 7 over 4. And f of 1 is simply 2 minus 1, 1, okay? So that equals to half times half times f of naught. Well, that's 2 plus 2 lots of f half, so 7 over 2 plus 1, okay? So it's a quarter times 3 plus 7 over 2. So I will get a quarter times 13 over 2. But total estimation equals to twice half of estimation. So I'm going to say 2 times a quarter times 13 over 2, which gives me 13 over 4. The answer is unit squared for the approximation to area, okay? So that is how you calculate the trapezium estimations with the simple values, fractions. Okay, let's have a look at Newton's method with a by-hand calculation. Well, Newton's method is used to estimate the x-intercept of the function f of x. And we want to verify the two inequalities. Basically, you need to calculate the values. Let's say f minus 1 equals to 1/3 times minus 1 minus 2 plus 4. So this is minus 1/3 minus 2 plus 4. Well, 2 minus 1/3, which is 5 over 3, greater than 0. But you need to show your calculation. You need to show this value, then say greater than 0. And f minus 2 equals to minus 8 over 3 minus 4 plus 4. Well, basically, this is minus 8 over 3, but it's less than 0. Verified. Okay, now Newton's method, remember, it's going to be xm plus 1 equals to xm minus the previous y value divided by the previous gradient, okay? So your x naught is going to be minus 1. F of x is simply third x cubed minus 2x plus 4. F dash of x, differentiating the function f, you should get x squared plus 2. So x1 is x naught minus f of x naught divided by f dash x naught. So this is minus 1, subtract. Well, f minus 1 is going to be 5 over 3. You already calculated that value from previous part. Okay? Then f dash of minus 1 is simply 1 plus 2 equals to 3. Okay? So I will be writing down 5 over 3 divided by 3. So that is minus 1 minus 5 over 9. And eventually, this is going to be minus 14 over 9. Okay? All right, so this is the x1. The first iteration gives me an estimation to the root of the graph. Finally, I've got a probability density function with a variable t here. And I'd like to find a value of k such that 90% of the telemarketing calls last less than k minutes, which means the probability of a random variable less than k is equal to 0.90, or let's say namely 9 over 10, okay? All right, so we are finding this k. Remember, if t is less than k, that is also greater than or equal to 0, or you could treat it like equal to, because this is a continuous random variable, okay? For continuous random variable, you could treat less than and less than or equal to as the same thing. So I will list an integration first from 0 to k, anti-deriving the probability density function. This is t, by the way, not k. dt equals to 9 over 10, isn't it? So the next step is anti-derive both sides, actually left-hand side. So I will get minus e minus 2 over 5t from 0 to k. Okay, in this case, if you have y equals to e minus kx, so dy dx is minus ke minus kx. So when you anti-derive ke kx, for example, you should get minus e minus minus kx instead, okay? With the minus to the front, add a c. But this is a definite integral, so I just write down an antiderivative with c equals to 0. Remember, the right-hand side is 9 over 10. Then you sub in the values, for instance, minus e minus 2 over 5k minus bracket minus e to the power 0 equals to 9 over 10. So 1 minus e minus 2 over 5k. This is 1, okay? Equals to 9 over 10. Therefore, e minus 2 over 5k equals to 1 over 10. Okay, now what I'm writing is, if you flip both sides, that will be e to the power of 2 over 5k equals to, flipping 1 over 10 gives you 10. And 2k over 5 equals to log e of 10. K equals to 5 over 2 log e of 10. Okay, so that will be your final answer. Okay, that's the end of exam 1 questions, the sample questions. Notice that there are only 7 questions, and they do not constitute a full exam paper. So you still need to use the other questions from various areas of study to revise for exam 1 for this November.